So today we're going to be looking at using comparative box plots. Basically all a comparative box plot does is it allows us to look at three different box plots, or doesn't have to be three, multiple box plots against each other, because they're all being measured on the same axes. And so you can see in this one we've got the distribution of marks in a test for three different classes. And I guess what we'd want to be able to talk about is which class is performing well, which class is performing poorly, and can we actually compare them. So the first thing to do is you can have a look up there in my little diagram there, that we can visually actually see things like range into quartile range and the 5-number summary really easily on a box plot. So it means, for example, if we wanted to compare who had the highest score out of the three classes, it's really easy. We just look at the maxes of each class and we can quickly see that class C had the highest performing student, or maybe the highest scoring student, followed by Class A and then Class B. Alrighty, so the next thing that we could look at is then the shapes of each of the classes. So you can see that for Class A, it has got a big long tail from the median down and not a lot above. So we would probably say that that is negatively skewed. For the next one, you can see that Class B is slightly tail on the right hand side, but it is very slight. So we'd probably say that it is close or symmetric. Class C, on the other hand, is skewed positive. It is far more stretched out on the positive side, whereas it's really closely compacted on the negative side, on the lower numbers. So we can write that down. Alrighty, so there we go. We've talked a little bit about shape. Now we can talk about the 50%, the upper 50% and the lower 50%. And this is where the skew thing really becomes a useful measure. Look at Class A. Class A, 50% of the people will always perform between the median and the maximum. Remember, we're splitting the data into 4 chunks. Each chunk is 25%. 25 plus 25, if we add 2 chunks together, we get 50%. So Class A, 50% of them are a 70 or above, and we can see 70 on the x-axis, right? So that means that Class A, its upper 50% are really closely together, and they're all scoring quite well. You compare that to the other two classes, and you can see that Class B and Class C, their 50% are getting 40 or above. So the median is really showing how much stronger Class A is and how much more consistent they are as a class. Alrighty, so there's quite a bit of analysis we could actually do. We could then go into more detail, which would be looking quartile to quartile. So we could compare this quartile to this quartile and this quartile. We could compare this quartile to this quartile and this quartile, and so on and so forth. We could compare the inner quartiles. We could look at the inner quartile range of all three of the classes and look at them and say which one's the biggest. Well, you can see Class A has the largest interquartile range. I don't have to calculate that. I can visually see it is longer, so it's larger. Same thing for range. If I wanted to look at range, I could look from the max to the min, and we could see really quickly, right? Class A is bigger range than Class B. Class A has a bigger range than Class B. I don't have to calculate what it is. I could work out all of these numbers just by reading them off the x-axis, but we're not being asked to do that. So, in the end, you have to compare what's really important. So the only other thing that I think is probably worth saying is that the lowest score, even though Class B performed really well, they're heavily skewed to the negative. You can see that this stretched out is the biggest region. It's so spread out. Yeah, their upper half is really, really consistent. Their lower half is super inconsistent, scoring between a 70 and a 10. The 10 being the lowest score performed by any student in the entire class. In the end, a question like this would make you really have to start and think and ask the question, which class would you rather be in? Would you rather be in Class A, in which half of the students are getting a 70 or above? Do you want to be in Class B, where students are on average, the median student is getting a 40 and the maximum student's getting under an 80? Or do you want to be in the Class C, in which their highest student got a 92-ish, which was higher than any other student in the whole class, but the median student, the middle student, is still getting a 40? And that's a choice. And that's how statistics helps us make choices. Doesn't mean there's only one answer. It means that it's going to help us make decisions. See you in the next one. Goodbye.